Hello again, friends. Today we're working on the Learn to Code 2 chapter array, and we are working on the activity called Generate a Landscape. We're going to have a lot of fun with this activity in a minute, but before we get started, I'd like to do a little practice activity where we review what happens when we nest loops. And this is going to be sort of a simple example of what's going to be going on in the Generate a Landscape activity in a minute. So to get started here, let's go. I've got Playgrounds open here. I'm going to open up one of these answers templates again. So if you don't see all these more playgrounds down here, you can actually go and click the See All button. What we're looking for here are one of these starting points, the answers template, and we're going to get one of these. What this is going to allow us to do is to print make some show statements that show different strings to the screen as we work. So after I made a copy, this is my 49th copy of answers. I'm going to rename this. Click on it once, then click on it again, and I might call this, say, Generate Landscape supplemental material or something like this. This will just remind me when I go looking back here for some of this code that we write today. It'll just sort of remind me, oh yeah, this was the supplemental material for the Generate a Landscape activity. So again, we go and open this up. This show command is what we're after here. This will let us show some message to the screen, and in fact it takes a string as an argument here and it shows whatever this string is. So if I run this, I can see it'll say what is your name when I run it. So here it says what is your name. Okay, and all we're going to do today with this is print some sequences of stars to the screen, and just to sort of show us what our algorithms are doing here. So nesting loops. The idea here, what we want to go back to is this idea of abstraction and composition, where abstraction is taking some sort of complex algorithm and thinking of it in really simple terms. Okay, so for example, if I say I want to draw a sequence of stars to the screen of some length. Okay, so if I want to do something like this, 1, 2, 3, 4, 5. If I want to print 5 stars to the screen, or 3 stars to the screen, or 111 stars to the screen, that's the idea that I'm trying to do. Okay, print some number of stars to the screen. So let's go ahead and make a variable here, an integer. Let's say let n be the number of stars that we want to print to the screen. So I'm going to say let n equals 5, and then I want to print that many stars to the screen. Well, we could, just put this in a show statement, but what we'd like to do really is do this algorithmically with a for loop so that we can change n any time and it will always work. We could change n to 111 and it'll print 111 stars to the screen. All right, so the way I think to do this is, let's go ahead and write that our objective down here. Draw a string of stars of some prescribed length n. Okay, that's it. So we're going to do this by constructing a string of that many stars. We're going to start with a blank string, and then we're going to load up stars to it depending on how many there are. So we're going to need to change this. So let's make it a var, and we'll just call it string to show, and we'll set it to an empty string for right now, because we're going to build up the number of stars that we need. And we're going to need n stars here. So let's make a for loop that says something like for some index I in the sequence 1 up to n. Okay, so I've got a for loop that's going to start at 1 and go 1, 2, 3, 4, 5 in this case, because it's going to go up to n. Okay. Now what we'd like to do is we've got this for loop that's going to execute 5 times. Let's add a star to string to show each time. So we'll say string to show, and we'll use concatenation plus equals a star. Okay, so that's going to build up, add a star to it every time this for loop executes here. Let me get rid of this for right now. All right, and then finally what we have to do is, instead of say show what is your name up here, at the end of our little algorithm here, we'll say show, and what do we want to show is just the string to show, like that. Okay, let's try this out. So we hopefully should get a string of stars that's five stars long, and there it is, 1 2 3 4 5, looking good. So just to review, we set n equal 5 here. Let's go ahead and make it 11, make sure it works. Good, there's 11. We created an empty string right here with nothing in it, a string with nothing in it. And we created a for loop that goes from 1 up until n, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we concatenate to string to show a star every iteration of this loop, and then we show that right in there. Okay, so again, what we've done here is we've created this, while it's only 4 or 5 lines of code, it's not very long. It draws a string of stars of some prescribed length. That's how we want to think of this abstractly, that we're drawing a string of stars of some prescribed length. We don't have to think about how it's doing it anymore. All these details are abstracted away. We're just thinking, how do I want to draw? If I ever want to draw a string of stars of some prescribed length, I just put this code in there and change my value for n. Okay. Great. Now let's create another goal here for ourselves that says draw a triangle of different sizes. Okay, and what I'm thinking about this is maybe something like this. This would be a triangle of length 3. This would be a triangle of length 4. This is a triangle of length 5, 6, and 7, and 8, something like this. So all we need to do is we need to say, oh, well, let's let n be 8, and it will, our algorithm will print out this triangle here. Okay, that's our goal. Draw a triangle of different sizes. So maybe say, we'll say in here, for example, size 8. And just because I'm going to keep, I'll go ahead and put these in a comment here. Oops. Put these in a comment so that I have know what I'm working with, what my goal is here. All right. So draw a triangle of different lengths here. Well, let's think about what this might look like here. Well, we know that at each one of these, there's going to be some for loop that prints a string of some length each time. Okay, so we've got a for loop, and it's going to print this line. It's going to print this line of stars, then this line of stars, then this line of stars, then this line of stars, this line of stars, and so on. So let's go ahead and say we want to know like how many, what our size of our triangle is. So let's say let size of triangle equal 8 in this case, and this will be adjustable. We can adjust this to any size triangle we want. And what's going to happen in our size of triangle is we're going to go through a loop and print different lines of stars. So let's make that loop here, and we'll say for how about we'll use j here, for j in we'll say for j in 1 up to size of triangle, like that. Okay, so that's going to print each one of these lines. Well, what do we want to do inside of each iteration of this loop? We want to print a string of stars. Okay, so we can take this code we have up here, which prints a string of stars of some length, right? I'm going to copy this. We could put it right inside here and say paste. Okay, there. Move this down a little bit. Okay. So I'm going to add some code here. some comments. This says number of lines to print, and then inside here we're going to say prints a string of stars of some length. Okay. Okay, so I don't know, let's go ahead and try this for right now and see what happens. I'm going to get rid of this stuff up at the top here. Let's get rid of these things. Okay, so now our code is going to start with n equals 11, and it's going to do this in here. And let's just see what happens here if we do this. Okay, not what we wanted here, but let's go through and look and see what happens. So up here we say let n equals 11. And then here we say size of triangle is 8, and we've got a for loop that says for j in 1, 2 size of triangle, so something's going to happen 8 times. And the thing that's going to happen 8 times is we're going to print a line of triangles of some length. And how long is that line of triangles? It's n. It's n, and n is 11 every time. Okay? N is 11 every time. It's going to print 8 lines of 11 stars. So that's what we've got here. 1, 2, 3, 4, 5, 6, 7, 8, and there's 11 lines in each star. All right. Now, that's not what we wanted. What we wanted was the length of each line of stars to change. We wanted it to be 1 here, 2 here, 3 here, 4, 5, 6, 7, and finally the last line to be 8 stars. So we can do that by changing this n here. We don't want this n to be always 11 anymore. What we'd like n to be instead, or the number of stars in here, we want it to be 1 the first time, 2 the second time, 3 the third time, and so on. Well, that's what j is. Okay, j is 1, 2, 3, 4, 5, 6, 7, 8. So if we change this n to be j, okay, it's going to be 1 the first time, 2 the second time, 3 the third time, and so on. All right, it's going to give us just what we wanted. A line of stars that's of length 1, because j is 1. A line of stars that's of length 2, 3, 4, 5, 6, 7, 8. Okay? Well, let's give that a try here. There we go. Okay, so that was our goal, is to print a triangle that goes 1, 2, 3, 4, 5, 6, 7, 8, and so on. All right? Okay, so again, we call this nesting a for loop, right? But you don't think about, when you're doing this, really, you don't usually think about, okay, I'm going to need 2 for loops, and what's going to be in the outside one, what's going to be on the inside one. Really, the way you want to think about this is think about it from the standpoint of, well, what do I want to do in each line? Okay, well, in each one of these lines, again, the abstract idea is to print a line of stars of some length. So write that part of it first, and once you've got that part written first, then you can embed that in another for loop and say, well, do that simple idea, drawing a string of stars of some length, some number of times. Okay, that's what we did. We said, okay, here's our abstract idea that says draw a string of stars of some length, and we embedded that in an outer loop that said, well, let's do that a bunch of times, some number of times. Okay. So just to be sure this works, let's go ahead and give it a different number. Triangle of length 3. Yeah, looking fine. All right. Now, one last thing before we go on to the puzzle here. What if we wanted to, instead of making this always increasing or always decreasing, like what if we wanted these to be some like random length or some different length? Like, for example, what if I had this list of numbers? I'm going to get rid of this stuff for right now. And get rid of this. What if I had this list of numbers like 5, then 3, then 4, then 2, then 3, then 1 or something. And I wanted my number of triangles to be 5, then 3, then 4, then 2, then 3, then 1, corresponding to each one of these elements in this list. Okay, well, we can do that too, and using the same idea here, right? This part's not going to change. We have code that draws a string of triangles of some length, but this part will change, okay? We're not going to just go from 1, 2, 3, 4, and so on to size of triangle. Instead, we're going to say, well, the first time it's going to be 5, then it's going to be 3, then 4, then 2, then 3, then 1, something like that, okay? All right, you're probably guessing right now, if you've watched some of the previous videos and done the previous activities, that we're going to work with this array here. An array is a collection of values or elements. In this case, these are a collection of integers. So let's go ahead and do that. Let's say let some array equals this array right here. All right? So we've got an array that's going to define our lengths of each line in here. So no longer are we going to be using this loop in here. What we're going to be using instead, I mean, we're going to use a loop, but we're no longer going to just sort of go from 1 to size of triangle in here. What we want to do is we want the first time through to be this, the second time through to be this, the third time through to be this, fourth, fifth, and sixth. Okay, so we need a for loop that does six times, that iterates through 6 times. So let's start with that here. Let's start at 0. And the reason I'm starting at 0 is because if I want to look at these array elements, well, this is the array element at index 0. This is the array element at index 1, 2, 3, 4, and 5. 6 elements. The indices are 0, 1, 2, 3, 4, and 5. So let's go ahead and say this is going to start at 0 and go up to, we could say, 5 here, 0, 1, 2, 3, 4, 5. We could do that, but we want to be able to, like if we come back and add some things to this, like this, we want to still be able to handle that, right? So let's make this be dependent on the length of the array. Okay, so we'll come back here and we'll say let's start at 0 and go up to array.count. Array.count will always give us the length of this array, the number of elements in this array, no matter how we change it. Okay, so that's our loop. It's going to start from j equals 0, j equals 1, 2, 3, 4, 5 in this case. Okay, all right. Now, how long do we want to draw each one of these lines? Well, we don't want to draw it 0, then 1, then 2, then 3. That's what this is saying right now. Go from 1 to j. Well, j is going to start at 0, then 1, then 2, then 3. What we really want is the array's value at that index j. Okay? So if I do that, if I say this is array's value, or value at index j, well, and I need to, yeah, that's good. So what I need to do is say, well, the array's value at 0 is going to be 5. The array's value at 1 is going to be 3. The array's value at 2 is going to be 4. 3 is 2, 4 is 3, and 5 is 1. So that this will draw, remember, if we're just abstracting this idea, we don't need to think about the details anymore. We just need to say, this code is going to draw a line of stars that's this long, which is going to be 5, then 3, then 2, then 4, then 2, then 3, then 1. Okay? Okay, which means we don't need this anymore. We're not using that. Okay, instead we're just going to go however many lines are in this right here. So let's give this a try and see if this works. Okay, great. 5, then 3, then 4, then 2, then 3, then 1. Excellent. Now, we've got an error here. It says index out of range. So I think it was last time or 2 activities ago we learned what index out of range means. That means somehow we tried to access an index that was either out here or before it. Okay? Probably of array. How could that have happened? We're starting at index 1, 2, 3, and we're going up to array of j here. J is starting at 0, then going 1, 2, 3, 4, 5, 6, because array.count is 6. There are 1, 2, 3, 4, 5, 6 elements in here. But remember, the last one is, because we start at 0, this is going to be 0, 1, 2, 3, 4, 5. Okay? So this is a bug here where we said go up to 6 for j, but there is no element 6 at j. There are only there are 6 elements, but they only go from index 0, 1, 2, 3, 4, 5. So we could fix this by saying array.count -1 will only go up to 5, or the other way to do it, I like this a little bit better, is to say in these ... here, you can change this to be a less than sign, and this would say for j in the sequence 0 up to but not including array.count. So this will go from 0 up to but not including 6, which means it'll stop at 5. All right, let's try that. There we go, much better. So that's working great, and we're not getting the index out of bounds thing here. Just to really round this out here, again, remember there's this other way to for loop here, which says if you're ever going to do everything in a for loop, you can go through the entire array and just get each value at a time. Okay, so can we do that with this? What would that look like? And it actually looks pretty nice. So let's give it a try here. How we would change this? This is great how it is right now. But if you wanted to change this for loop to a for each loop, you could do something like this. So I'll say here for, and the way this looks is we say something like for n in array. We want to do this here, and the thing we want to do in here, I'm just going to get rid of these for now. I'm going to back this up here, and we're going to say for n in array, we want to do this. Let's fix the spacing here. Okay. Now, what is this doing here? For n in array says for every element n in this array, which is going to look at 5, then it's going to be 3, then it's going to be 4. So we're talking about n here. N is going to be 5, the integer 5, then 3, then 4, then 2, then 3, then 1, if we do the for loop this way. Okay, which is nice. That gives us everything we need here. Then we want to create a string of length 5, 3, 4, 2. We want to create a string of length n. Okay, well, no longer do we need to say array of j in here because the length of the array we want to make is n. Okay, so this, it might even look a little nicer to you. You can do it either way, it's fine. But here we're saying for every element in array, 5, 3, 4, 2, 3, 1, make a string of length that long, n. Okay, let's try that out. There it is, 5, 3, 4, 2, 3, 1. And just to be sure this works, let's do an 11, 10, and a 9 at the end here. Add a few things, so we should get, our last one will be 9 long. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks good. Okay. Great. Let's go back now and take a look at the activity here in our Learn to Code. And this is generate a landscape. All right, in this activity, generate a landscape, our goal is to use an array of integers to create landscapes. I'm going to close this up here. Okay, generate a landscape using an array of integers. So this is going to be a little bit similar to the activity we just did. It says the code at the bottom of the page contains 2 arrays, heights, stores integer values, and all coordinates stores all the coordinates in the puzzle world. Okay, and we've worked with all coordinates before. All coordinates basically is going to give us each one of these coordinates in a long list. Okay, it's going to give us 0, 0 first, 1, 0, 2, 0, 3, 0, and so on. Or it might even go this way, then this way, then this way. I'm not sure which way it goes right now. But we'll figure that out in a minute. Use the heights array to determine how many blocks to stack on each coordinate in all coordinates. So we're going to be stacking blocks of land on each one of these coordinates, and the heights array is going to tell us how big or how high each one, or how many blocks we're going to stack on each one of these coordinates. Okay, to do this, you'll need to access specific integer values at each index in heights. So, for example, here's an array, heights, which is 7, 3, 2, 4. Then there's a for loop that says for I in 1 up to heights at 0. What's heights at 0? That's the first element of heights right here. Okay, and so it's going to, this will do a loop from I equals 1 up to 7 in this case. So because the value of heights at index 0 is 7, this for loop will run 7 times. And let's check out what's happening in here. So we've got a nested for loop. Let's not worry about the outside one for right now. Let's just look at this inside one, which says for I in 1 to heights at some index. So if heights at index look like this, it would be an index were 0, which it is. That number would be 7, and this would say do a for loop that goes from 1 to 7, world.place some block at that coordinate. So this loop is going to stack 7 blocks at the first at a coordinate, and then right in here, this is saying we're going to do this at every coordinate. So for some coordinate in all the coordinates, place maybe not 7, but place some number of blocks here, because look what happens. After we place the 7 at the first block, index changes to be 1 more. So index, when we come back down here into this loop again, heights at index will not be heights at 0, it'll be heights at 1. So heights at 1 is 3, so the next time through the block, it's going to print or stack 3 high. Okay, because index changes every time, we're going to be looking at this element in the heights array, then this one, then this one, then this one. We're going to look at each one. Okay? Okay. Now, so that'll take care of the first. We're going to get 7 here, then 3, then 2, then 4. Then it says be careful, if the value of index is greater than the number of items in the heights array, you'll try, like if we end up with trying to access some value of heights, some element of heights that's out here, there is none, so we'll get an index out of bounds, an index out of range error, and we're going to need to do something with that in there. Okay, so let's look at that in a little bit here. So come down to the code here. So we've got a variable heights, that's an array of integers. Okay, and let's go ahead and add the integer values in here. So we can make these whatever we want, but for right now, let's go ahead and do what they had. Okay, 7, 3, 2, 4. Okay, and all coordinates, well, I remember how we get this here is we say world dot, I think it's just world dot all possible coordinates, right? So all coordinates is going to contain an array that has these different coordinate values. And remember, a coordinate has both a row and a column, okay, for each one of these. Okay, then we're going to do the same loop we had described up above. We're going to look through every coordinate in the array. Skip this for right now. We'll come back to this in a second. But now let's look at what are we going to do at every coordinate in the array. Well, we're going to say let's do some number of, stack some number of blocks there. So for, for I in 0 up to heights at index, and the index is going to be here. We're going to place a block, and we'll do it like they did right up above. We'll say world dot place some new block at coordinate. Okay, like that. So that's going to do this 0, 1, 2, 3, 4. But remember here, if we start at 0 and we go to heights at index, that's not going to print just 7 blocks. That's going to stack up 8 blocks because it's starting at 0. So let's use this little trick we used before, and we'll say, oh no, that's not, yeah, we'll say let's go up to but not including heights at index, something like that. Okay. Okay, there we go. That's going to place those blocks. And then down here it says let's increment the index. So we want to start at 0 and do this one, then 1, then 2, then so on. So we'll say index plus equals 1 in here. All right. Let's comment this out for right now. because we didn't look at what this even does. And let's run our code. We hopefully will get 7 blocks placed here, then 3 next to it. So 1, 2, 3, 4, 5, 6, 7. 2, 3, 1, 2, 3, 1, 2, 1, 2, 3, 4. Good. And then we get a little bit of a crash. Index out of range. That's kind of what I expected to happen, because we're going to be trying to access the 5th element of this index here. And that's not really what we wanted to do. What we want to do is maybe after we get done with 4, let's come back and start over with 7, 3, 2, 4, 7, 3, 2, 4, 7, 3, 2, 4, and so on. So if our index ever gets up to be greater than 0, 1, 2, 3, if our index ever gets to be greater than or equal to this one up here, then let's reset it back to 0. Okay, and that's what's happening in this for loop here. It's saying if we ever, before we get going here using index, if our index is ever at heights.count, which in this case it's 4, if our index is ever 4, make it be 0, and that will change it back to 0. So that's inside this loop, and it says we're looking through coordinates. This is 7, this is 3, this is 2, this is 4. If we ever get to here, we're going to set the index back to 0, so it's going to start looking at the heights 7, 3, 2, 4 again. So this will be 7, 3, 2, 4, and so on again. Okay. Let's take a look and see if that'll go here. In fact, I might make this run faster. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 2, 4. Back to 7, 3, 2. 7, 3, 2, 4. 7, 3, 2, 4. 7, 3, 2, 4. 7, 3, 2, 4. 7, 3, 2, 4, and so on, all the way through here. Okay, I'll let that run here until this gets finished, just to see what happens at the end while we kind of review what's going on. So again, inside a nested for loop in here, let's break down each loop and sort of abstract that idea. So what is this doing here? This is placing it's making a stack of blocks some height. So I'm going to go ahead and make a note here. Make a stack of blocks of some height. And what height are we going to make it? It's going to be heights at some index. At some height, heights at index. Okay. Bad typing today. There we go. Heights at some index. And heights of some index is going to, sorry about this spelling there. And heights at some index is going to change each time to be 7, 3, 2, 4, 7, 3, 2, 4, because heights is an integer array with elements 7, 3, and 2, and 4. Okay? Looks like this almost made it, but it may have stopped for some reason. Interesting. Oh, it probably stopped because I was changing the code in here. We'll run it really fast. Run fastest just to make sure that goes through here. Okay, after we're done with this, I want to play around with this a little bit and try to maybe change some things here too. Let's change this array, for example, to have more. Yeah, that worked just fine. Let's go ahead and change this array to include some other numbers here. 7, 3, 2, 4. Then what if I went to 8, 1, and then 5, something like that. Let's include some more things here. Will this work? Okay. Well, heights now has 0, 1, 2, 3, 4, 5, 6. So it has 7 elements with indices 0 through 6. So our coordinate is going to go through all coordinates. This is going to start at 0 and go up to, but not including 7. So this should work fine. And if we ever get to 7 here, heights.count, the index will switch back to 0. So I think this should all work just fine because we wrote it so that it was generic and could work in any case here. So there we go. Okay, if we want to do anything else with this, yeah, we could do something else with it. Let's build up an array of maybe, random heights, say. What if we wanted to put a different height in for every single coordinate in here? So this could be challenging, but let's give it a try here. So let's create an integer array and let's put nothing in it. Okay, for now we're going to build up an array of random integers, and there's going to be a different random integer for every one of these in here. So I'm going to look at how big all coordinates is. Okay, so let's come here and we'll say, let's first make a new integer. This is going to be some new random integer we're going to make. I'm just going to set it to be 0 for right now. And let's make a loop that we're going to add some elements to this heights array here. And we're going to add a lot of elements to the heights array, whatever this is, 9 by 9. So maybe 81 different elements in here. So let's say for index in the range 0 up to but not including all coordinates count. Okay, all coordinates count. So we've got a loop that goes through there, and we're going to create a random number. So let's say I'm going to say call random, some random number equals a random int. And here's a little function that creates a random integer from some value. And the from values will say it can be as low as 0, and it can be as high as maybe. Well, I'd like to make it as high as these as the number of columns there are. So let's see if we can actually do that. Let's say all coordinates dot. What do we have here? All coordinates dot. Actually, no, we want to look at an index in here. So all coordinates. So an index of all coordinates would be this, like this. So if we're going from 0 to all coordinates of index. So what we're trying to do here is, let's just make a random number. Let's try this for right now. Some random number between 1 and 21 or something like that. Okay? And we'll go ahead then, is after we do this, we're going to append it to heights. So our heights array dot append, the new element is going to be call random, something like that. Okay? So this is creating a random number between 0 and 21, and we're appending it to heights each time. So this is just giving us some random value. Now heights is super big. It's got something like 81 different random numbers in it. So when it comes through here, this should work just fine. Now you might be asking yourself, can we still use the index variable here down below? And we can, because this index is only defined inside this for loop. So after this for loop is done, the word index can be used again as a variable just fine, because this index, we say it has scope of this particular for loop here, and it doesn't have scope outside. So this is a brand new version of index, so that should work just fine. So here we should get some random number, or random heights from 0 to 21 as we go through here. If we were to print out the array heights now, it would have, I think, 81 different random numbers in it, all in the range from 0 to 21. So that's pretty cool. Looks like it's working fine. Oh, there's one that was 0 down there, or at least one. Okay, we'll let this finish off here, And what if we wanted to do sort of a random number that depended on where we were in the puzzle? Okay, because we're trying to generate a landscape here, and this is a very random looking landscape. It's not that useful, I don't think. So let's think about this a little bit. What if we wanted to make a random number that was, again, if I click on these things, this is 8, 0, this is 8, 8, okay? So let's say we wanted to make these values here be high, like mountains, and these values over here at 0, 0, well, that's 0, 0, trust me, be low. We could make our random number be dependent on where we are in this grid. Okay, so if this is 0, 0, these will be small random numbers, and 8, 8 would be large random numbers. Okay, so one way we could do that is we could get the value that we're at here. Instead of using the same number, 21 here, let's get the column value that we're at and choose a random number between 0 and that. So if whatever column we're at here, well, the coordinate we're at is called all coordinates at some index, like that, and we could get its column like that, its column value. So this would create a random value between 0 and 0 if we were at column 0, or it would create a random number from 0 and 8 if we were at column 8 in this case. So I'd like to be this a little more exaggerated. Let's maybe, I don't know, multiply this by 2 or something, the column index. And then let's also create one for the row index. So wherever we are in the row, we'll get a random number that's dependent on the value of row. So for row random, it's going to be a random number between 0 and the row of the current coordinate times 2. And then let's just maybe add these values together, something like this. New random index is just going to be equal to col random plus row random, something like that. And the size that we're going to add now is just going to be new random index, something like this. Okay, so what we're going for here is a random number, but the random number, the size of the random number will change based on where you are in this grid. If you get up higher into the columns, you got more of a chance of being a higher random number, and as you get higher up in the rows, you have more of a chance of having a larger random number for the rows. And then we're going to make this, our random index, be dependent on both of those values, where you are in the columns and in the randoms, by adding them up. So at the end, you've got a chance to be, when you're over here on 8, 8, you've got a chance of this being really big, but when you're down at 0, 0, it's going to have to be 0. Okay, but it'll gradually go up. So our goal is to get something like a little mountain range here, maybe. So, okay, as you get higher over here, at bigger columns and bigger rows, they get bigger, and that's pretty good. I think it's working. These are 0 here. And as you get further out towards this corner over here, they should get bigger and bigger. So that's good. I think it's a little too much, maybe. Yeah, I'm going to go ahead and stop this. Maybe we didn't need to multiply by 2 here in each of these. I think that's just making this a little bit too extreme for what I was after. This is looking better. Okay. Nice. So this is going to create a little plane over here where all these were kept down at 0, but the further you get out here, the higher the mountains are. So this is making a little bit of a more realistic landscape, I think, in the true spirit of this activity where we're generating a landscape. Yeah, I like this. That looked nice. Let's take a look at this. Over here. Very nice. Okay. So that's pretty good. You can play around with these values if you want to make your landscape look a little better. In fact, maybe you want something a little more subtle. We could divide these by 2 each time. Get kind of a little hill thing going. Let's see if this does anything useful. Yeah, so same idea, just a little more subtle. but nice. Okay, that's it for today. The main ideas here, again, we're talking about nested loops. And remember, when you think you're going to need a nested loop, don't just dive in with, putting your 2 for loops in there. Think about this abstract idea of what's going on in the inner loop, then write that loop first. And then go ahead and embed that in another loop outside and say, well, how many times do I want to do this abstract idea that's in the middle of our inner loop? Okay. All right. Go ahead and like and subscribe this if you feel like it. We'll see you next time. Bye-bye.